Okay, next topic is going to be cam table attacks, where this is an attack against the switch's cam table, where the switch keeps the dynamic and static entries of MAC addresses it has learned from frames. So in general, switches are going to dynamically learn the MAC addresses to scale and perform better from the switching point of view. So they're going to always, when a switch receives a frame, is going to take the source MAC address of the frame and put an entry of MAC to interface binding on the interface it has received that frame on. So it is going to do MAC address learning from the source MAC address of an Ethernet frame. So MAC learning is done based on the source MAC address. So MAC learning is done based on the source MAC address of a frame, but then when a switch has to forward the frame, when it receives the frame, it looks at the destination MAC from the Ethernet frame, and then it's going to look in its cam table to see, do I know where to find that MAC address? And if yes, I'm going to send the frame only on that specific port. That's the optimization. That's why the switch does MAC learning. So each switch, you can imagine that the cam table is being held in a specific memory portion. It's actually holding TCAM, temporary tertiary cam, which is a dedicated portion of the hardware ASIC that is used by the switch. Either way, based on the switch, let's say size and switch model, that cam table has a specific size, which means the switch can learn a specific maximum number of MAC addresses. And what happens if let's say the switch can learn up to 1,000 MAC addresses, if it has learned 1,000 MAC addresses, it means that the switch can no longer do MAC address learning. So it means at that point that the switch is going to behave like a hub. So at that point it means that the switch is going to send, whenever the switch is going to receive a frame for which the destination MAC is unknown, it doesn't find it in the MAC address table, is then going to send that frame out on all ports and all VLANs. It's even going to cross the VLAN boundaries, unfortunately. That's why it's going to behave like a hub, because the hub doesn't have the concept of VLANs. So if the cam table of the switch gut is full, can no longer learn any new MAC addresses because it's full, then at that point, when a switch receives a frame inbound from VLAN 9, it's going to send it out on all ports regardless of what is the VLAN associated with those ports. So you're going to send that frame received from VLAN 10 into VLAN 20, 30, 40, 50, 60, all VLANs which it has connected up and configured. That's clearly a bad thing to happen. So it's easily to overflow the cam table to the MAC address table size. Basically, the attacker is going to send many frames very rapidly, and within a couple of seconds, he's going to send many frames with spoofed and random source MAC addresses, which is going to end up depleting the size of the cam table on the switch, and the switch is going to end up not being able to learn any new MAC addresses.